My name's Nick. I started Nick's Electronics Repair about 10 years ago, and since then we've fixed over 27,000 devices. In today's video, I'm going to be showing you how we fix a Bobcat controller base. The customer that sent it in stated that they had some water damage that entered through this broken glass. Right now, I have it connected to power, but the unit won't even turn on. So let's open it up and take a closer look inside to see what we need to do to fix it. So the customer already had opened it up, and they sent it without any screws. Normally there are screws on the perimeter, but in this scenario, we can go ahead and just lift off the back cover. And one of the things the customer did was they taped down a pin. And if we look at the controller base, right here is the missing pin. Zooming in a little bit more, we'll also notice right here, this pin is completely rusted. If I bring this at an angle, we'll notice this one is also starting to rust and has heavy corrosion. And I think some of the others might also need replacement, but they definitely all will need a cleaning. So we're gonna wanna start with that. So let's start by removing the foam pad that's sealing the pins. Okay, something we're noticing here, it might be hard to tell on camera, but one of these pins right here is actually also bent, so we're probably gonna want to replace that one there. If we take a look over here, you'll notice the first 4 pins are very shiny, and this one's very dull. So there is definitely a layer of, I think maybe the start of corrosion. So we're gonna use this little Dremel tool to try and clean it up and see if there's any sort of physical damage that is significant, or if it's just surface damage and that we can just clean it up with this little tool. Okay, it looks like it's actually in decent condition, so I don't think we'll need to replace this one. We'll do a more in-depth cleanup in a moment, but I think we're okay on this one at least. Let's see, let's move on to here. So this one near the base does look like it has a little corrosion maybe. Again, let's check out to see if it's just surface level. Okay, and it does look like it was surface level. And these guys, so also kind of at the base. So what I'm thinking is some of those foam pads probably retained some moisture, and that's why we have a little bit more corrosion near the base of these pins. So obviously this one had a lot of corrosion and rust. If we look at the pin back here, it does look a little orange, which would indicate rust. Okay, and it looks like we got rid of it, so that was just a surface level. But if we look at this one, as you can see, I can significantly dig into the pin, and now there's little chunks missing out of it. And as you can see, I can actually very easily bend the pin, and if I do that a couple times, it should break off. And the same is gonna apply to the one behind it right here. All right, so as of right now, I've identified 1, 2, 3, and 4 pins that we're gonna wanna replace. So let's remove the PCB out of the casing completely. We'll flip it over. And I wanted to take a look at the back to see if there was any damage back here. It actually looks okay. So what I'm gonna wanna do is just remove some of that silicone layer that's coating the pins. We'll do that on both sides, and that's so that I can make sure to get good contact with my soldering iron to the pins and the joints. Right, and we'll do this one. And then lastly, we had this one over here that was bent. And I'm gonna use my metal brush to clean off the rest. Come back and do the same over here. We can start our soldering. So to desolder these pins, I typically will start by adding fresh solder to the joints. And that's to make sure we get good flow. I'm gonna try and remove as much of the newly added and original solder as I can.
The reason I'm doing it this way is because desoldering corroded or rusty solder is really tough. These pins are also very snug and difficult to desolder, so to make it easier for myself, I want to remove as much of the original solder as I can, and adding fresh new solder makes that process a bit easier.
Let's go ahead and clean off some of that silicone on the top as well. And we'll do the exact same process on the top side. I am having a bit of a hard time getting my heat to transfer from the iron into the pin, and that could be just because of the rustiness of the pin. Okay, this one, it does look like I'm getting a little bit better heat transfer. I'm gonna try adding some flux to the first pin. My understanding is it's gonna help clean up corrosion, imperfections, so that I can get a better heat transfer between my iron and the medium I'm soldering to. But the reality is we are also just soldering to a rusty piece of metal, so it may not really have much of an effect. All right, that might be the best we're gonna get. So let's just desolder as much as we can now, removing both the newly added solder and as much of the original as possible. All right, let's give that a bit of a clean. All right, so I cleaned up both front and back, and we still have more solder in there that I can't get out, which is okay, and that's what was expected. So at this point that I've gotten the majority of the original solder removed, I'm going to recoat it again with our fresh solder. And for this one, we're actually gonna switch over to the microscope. And what we're gonna be doing here is, with my needle nose pliers, as I'm melting the pin from the back, I'm going to pull the pin from the front. And there we go. We have the first one. We'll repeat the process with the back one. Okay, and you can see the pin moving on the back, so it's loose. So that means I can start pulling, but we want to be gentle. We don't want to pull the whole joint. And it looks like that was a clean pull. All right, we'll keep adding some heat and desolder. We still have some solder in there. Might have to desolder from the front. Yeah, we might have to do that. I'm also gonna add just a little bit of additional fresh solder. I wanna make sure we get good flow here. I'm not really getting that flow I'm looking for. Let's try to desolder anyways. Yeah, I can tell the braid's not absorbing as much as I want it to. Let's see, let's clean up the area just a little bit. Okay, and it looks like my solder flowed through to the other side again. So we're playing a little cat and mouse here. So this time around, I'm going to add some flux first, and hopefully that will be what we need to desolder it all first try. I don't think it worked. No, it did not. What I'm gonna do is I'm going to actually just drill out the rest of that solder. There we go. All right, and that looks pretty good. Let's move on and repeat the same process with this one over here. So again, we'll want to clean up some of that silicone. Yeah, I'm having a hard time getting the solder to bond to the metal of the pin there. Okay, I definitely got much better flow on the backside here. I'm just hanging out on the joint for a few extra seconds, really warming up both the joint and the pin. And now we can flood that pin. Oh, there we go. Now we have movement. And there we go. But it does look like I might have ripped the pad off. All right, let's go ahead and clear off some of that solder. From the back, it looks okay, but on this side, yeah, it does look like the pad has gone. Let's clean it up and just double check it. Is it perhaps just a no connect? And if that's the case, then that means it's fine. And most likely why it got pulled, because it's not actually connected to anything. So there's a little bit less reinforcement and strength on that pad. It's just glued to the front, and that does look to be the case. I'm gonna do this last one over here that is bent off screen, since it's the same process again. So we have our replacement pins. We're just gonna feed them through from the top, and they are very snug. So I am putting a little bit of pressure with the needle nose pliers, kind of wiggling them in. And that is also why they're a little bit difficult to remove, because they are really in there snug. All right, so they're almost through. What I'm thinking is I might just start soldering them down and then kind of finalize their position once they're soldered in. And my pin is, like I said, still a little bit high. Oh, and it just went through. Okay, let's go ahead and do the same with the next one. Okay, there we go. Same thing. Oh, this one's twisted a little bit. That's better. All right, yep, they're about the same height as the rest. So that's good. Next we have this pin. All right, and then our final one is over here. And that one's giving me a little bit of trouble. And it's most likely because I probably didn't clear that area of solder properly. So what we'll do is start by adding some solder on the back, try and get some good flow. Okay, we have good flow on the front. Okay, and actually it is flush now. And if you take a look, it was the middle one, so it is now level and flush. Now that all of the pins are fixed, let's go ahead and bench test it one more time, see if we can get power. Let's see. Okay, and it looks like it is turning on. So we have our display. Let's see, if I turn it off and on, our gauges are moving, our display is working, our lights are turning on. So it looks like we have it fully functional. Now, even though it looks like we have properly fixed the unit, I do want to do a close check to make sure that there isn't any other sort of water damage that might not be affecting it immediately today, but if left untreated, might actually have some consequences down the line. So let's go ahead and do that next with the microscope. So starting on the pins, everything is a little bit dirty and dusty, but that's okay. We'll do a little cleanup for that in a moment. That's the area we soldered. Another area was soldered. Okay, so over here, there's something suspicious. It looks like some of the silicone got eaten through and has exposed some of the copper. Let's see. Well, right now it doesn't look like there's actually any damage other than just some delamination. So that should be okay, nothing to be concerned about, but that is something we want to clean up, which is what I'm doing with the metal brush, just removing any potential dirt, moisture, corrosion. And typically what I like to do is add a little bit of solder to that area just to reinforce it. It'll also coat it a little bit. We'll add some flux for better flow. So now let's do a clean to remove some of the flux. And what we'll do before we send the unit back is we are going to coat it with our own conformal coating so it's nice and sealed and water cannot damage it further. All right, let's keep looking. All right, another area that is suspicious right here. I don't know if you can see it, but there's a little bit of blue and a little bit of blue. Usually that means corrosion. So we'll want to scrape that off. And the fact that we are getting so much delamination does confirm that those areas were definitely affected. In contrast, an area that's not affected, you can see there's no copper exposure going on. And so that means that this area was not affected, this area was affected. But again, it looks like it's just delamination. It doesn't look like it's anything more than that. So nothing too serious to worry about. But again, we're gonna wanna do the same thing. We'll clean it up, reinforce it, and do another clean before we seal it with the conformal coating. Let's keep going. Yeah, we have a little bit here and there. We definitely have some over here. Yeah, so it's looking like some of this silicone might have actually trapped the moisture and more or less locked it in some areas. I'm not always getting good flow everywhere. Some of the areas, the copper is just not exposed enough. But that's okay, it's gonna get sealed with the conformal coating anyways. Just wanna make sure we do a good job cleaning it up, cleaning up all that flux, otherwise the conformal coating won't seal it properly. It won't adhere to the PCB. I'm gonna do a quick little continuity check. When we get a beep, that means we have continuity. And we do. Okay, just wanted to make sure because that looked a little suspicious there. You know, at this point, I'm just gonna keep looking around and then we'll come back. A little bit of corrosion there. Okay, we'll want to reinforce that joint, maybe reflow it. Okay, let's keep looking. Oh. This line over here, a lot of blue. That's corrosion. Let's keep going. That's not too bad. Oof, all right. And it looks like this corrosion isn't, for the majority, actually causing problems right now. It looks like it's more or less just trapped on the surface between the silicone and the PCB. So it's not a big issue, but we definitely need to clean that off and then coat it, reinforce it, so it doesn't cause problems in the future. So we're gonna go ahead and do the majority of this cleaning off screen because that's kind of boring. Now, if I do send it back as is, the customer will still have some issues at the next rain or weather event. So we're gonna want to go ahead and replace this glass with brand new ones so that we have a nice seal and we don't have an issue with water coming in through these cracks. So for this part, we're gonna actually break it more. And we obviously have to be careful. We don't want to cut ourselves. Do a quick little cleanup, remove some of those smaller shards. And we just want to try and get under it, loosen up that gasket. There we go. I fully cleaned up the area for our new replacement piece. I'm going to apply my new gasket. And that was more than I wanted, but that's okay. Yeah, that's gonna be more than we needed. We're gonna press the new piece in, and while the gasket is still wet and not yet dried, We're gonna remove it. All right, so it does look like everything is operational. Our stepper motors are spinning as they should. We have now full power, and we did replace the compromised glass. So if you do have one of these Bobcat controller bases that you would like to send in for us to fix, we do offer the flat rate services, which come with a 1-year warranty. Those are available on our website, which I will link in the video description down below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.